Raluca. She has a PhD in intelligence, or is working on her PhD in intelligent games and games intelligence at Queen Mary University in London. She's currently doing a 3-month internship at Microsoft Research in Cambridge. And what she's going to be talking to us about today is learning to play the multi-agent reinforcement learning in Malmo, or MARLO, competition. So, welcome, Raluca.
Thank you. Hi, everybody. My name is Raluca, and as I was very nicely introduced, I'm still studying for my PhD at Queen Mary University of London, and I'm currently an intern at Microsoft Research in Cambridge, working on a very fun project that I'll be talking about today. Usually my talks are sort of focused on the research papers, all the polished research that's nice and ready to go on a shelf. But today I'm mostly going to be talking about a direction of research instead, and a new project that I would actually encourage you to do the hard work. Although there may not be that much hard work to do, because us academics are famously or infamously known for coming up with these brilliant solutions before we actually have a problem. So we go running around trying to find a problem to actually apply our brilliant solutions in. But fear not, I have a problem for you today. And I'm guessing this is how I see slides. Okay, good. So I'll be covering 3 topics today, and starting from games and artificial intelligence in games, why we like games, why they are good for AI, and I'll be moving on talking about Minecraft and how it can be used as a platform for AI research. How many of you are familiar with Minecraft? Hands up. Okay, there's a couple of you. Good. And lastly, I'll be talking about a new competition that we're organizing this year that will be on multi-agent reinforcement learning in Malmo. That's called MARLO. Starting from games and AI. Games have been used as a platform for AI for many, many years, and a lot of the advancements in AI can be pretty tightly linked to games. Games like chess and Go have helped push the state of the art in AI methods such as alpha beta, Monte Carlo tree search, or deep learning recently. But why do we like games? There are many reasons, of course, but for this particular application, they are complex problems that can also be broken down into smaller tasks that can be easily achievable with AI methods, but they can also be scaled up very easily and the complexity increased until we get to that point where the challenge is suitable for what we're looking for. They are also cheap compared to things like robotics, where if a robot breaks during an experiment, to replace that and fix it, it would be a lot more expensive than just patching up a game and running the experiments again. And games are also very fast to simulate, so we can get very quick feedback to find out if our methods are actually any good or not before we apply them to real problems. Although games are real problems in themselves, sometimes we look at games and how they push the state of artificial intelligence, but we can look at it the other way around as well, as modern games make more and more use of artificial intelligence in different ways, like non-player characters or companion AIs, or even generating content, and that's a whole area just by itself. You can generate novel content, new levels that surprise the player, new storylines, or even games that adapt to the player and their individual play style, and making the experience fun every time they play. So because we like games, we like AI, some of us in the research community like to run competitions on game AI. Many competitions have been run over the years on some very specific games, and a couple of nice examples are Super Mario or Miss Pac-Man. And competitions are great. They encourage researchers to sort of compete, hopefully in a friendly way, to create better and better methods that improve incrementally. And they're also great because they allow methods to be tested in the same environment and under the same settings. So you can for sure say that one method is better than another because the testing was nice and fair. Why these are bad, though, is that they specify on one particular game. So methods that will be good in Miss Pac-Man will probably fail miserably in a car racing game because they don't know how to drive a car. And what would actually be more useful to artificial general intelligence, which is sort of what we're aiming for, is having one agent that is able to play a range of different games. So it sort of learns from its past experiences and adapts to new experiences that it maybe hasn't encountered before. And I should pause here and say hooray for Microsoft Research winning an award yesterday for innovation in artificial general intelligence. So we're doing the right thing, I guess. And there are quite a few frameworks that look at promoting this sort of research in a general way. I can't really go into details on any of them, but I can mention a couple. And the first would be the arcade learning environment that looks at 2D arcade games based on the Atari collection. And the general video game AI framework that also features 2D arcade games in different genres. There are currently 160 of them, and more are added every year. And this framework also promotes planning in games and content generation as well as adversarial AI. So we have two-player games alongside the single-player ones to get agents competing or cooperating with each other. And I'm actually the organizer of the two-player track in this competition, so you are highly encouraged to follow the link at gvgi.net and check out the competition. Very good. But I'll be moving on to talk about Minecraft. These frameworks that I've mentioned, they use very simple 2D games, although their approach is great at looking at general AI and testing across a range of games. They still do keep it at very simple games, sometimes quite static. And what Minecraft offers is this huge complex environment in 3D as well, with a lot of opportunities. So Project Malmo, that was started by Microsoft about 2 years ago, sort of exposes this world of Minecraft to AI research. The project is publicly available on GitHub, so you can go ahead and play with it. And it's currently widely used in research, as well as by some non-profit organizations for teaching coding and AI basics, and also used in some machine learning classes by some universities. Malmo is based on several design principles that are very simple, starting with having a low entry barrier and yet a powerful system. So what this basically consists of is a mod to the Minecraft game that exposes state observations and rewards, as well as listening back for commands from the agent. Then we have an API that allows for a communication between the environment and the agent. And finally, a set of tools that basically describes the agent that we actually want to play in the game, as well as the actual task that we want the agent to solve, because this is still a very much broad and open environment. We still have to start from a smaller problem and narrow down the task with specific goals for the agents. Secondly, we want to go beyond narrow AI with multitask learning. And how Malmo does this is by making it very, very simple to create new missions. That might look complex and scary, but it's actually a very small XML file that all it does, it describes how the world is generated. Then you can customize it by adding multiple blocks or entities that you might want your agents to fight against. And then you're describing what your agent sees, what rewards it can get from the environment, and how it can interact with it. And these are some examples of games created by students in a project run at the University of California. And that's a nice way to showcase that many games can be created that are very, very fun and diverse. And finally, we have the final principle, which is being wired for multi-agent tasks, including human agents. Now, when you have an AI in a game, you want it to eventually be put back into a commercial game, and that can be as a non-player character, for example. And in that situation, you want the agent to be able to interact not only with the world that it is put in, but also with the other characters in the world and the player themselves. So they have to have this ability to handle interactions with multiple agents. And Minecraft lends itself very nicely to this multi-agent learning setting, as players themselves have already created games within the larger game of Minecraft, things like Capture the Flag, Battle Royale, or even football. And last year, Microsoft decided to run a competition. This was going along with the multi-agent idea. So this was run on a very, very specific game. So we have two players that are basically in a pig pen, and they are running around chasing a pig, trying to catch it for a large reward. Or if they realize that their partner is not really cooperating, they can choose to exit the pen for a smaller reward. And that was an interesting experience. There were some very nice successes and some very creative techniques. You can check out more details about that on the link at the bottom. But the problem with this was that it was still overfitting to one game. We had multiple agents, that was great, but there was only one game. So this year we're trying to expand that by having multi-agent learning, but in multiple games. So we're organizing a competition, which is organized by a consortium formed by Microsoft Research, Queen Mary University of London, and EPFL. And these are sort of the main organizers of the competition, but the team has grown quite largely since then. And the idea of it is that instead of focusing on one game, we're going to be testing AI agents on a range of different games. So, and even within one particular game, we're going to have variations of it. Things like the layout of the level, the size, or even the look of it. The agents will all have, they will be able to access variations of all of the games publicly to be able to train on them and understand the sort of challenges they might face. But in order to keep this truly general and be able to test that the agents are able to handle situations that they really haven't seen before, we're going to be testing them on variations of each game that are secret and they have truly not seen before. Some examples of the games that they will be playing on are Build Battle, in which the players have to simply build a structure that is given to them. So they basically just have to put the blocks in the right places to copy the structure so that it matches, which may sound like a very simple task and trivial for a human, but the agents do have real problems actually managing to solve this. And we're also going to add Pig Chase, which is the game I was describing before, with the agents chasing the pig around. And this one will be added in order to test that the agents submitted last year see how much they actually overfit to the game, how they can handle variations of this game, and even completely new games that they haven't seen. Some examples of how a task may be varied. These are on Pig Chase, where we can see different weather, different times of day, or even different animals that they would be chasing around. So they can no longer look for a pink thing running around the level and decide, okay, I'm playing Pig Chase, I know what I have to do, I just have to catch the pig. They can no longer do that. So we have a draft schedule at the moment. We're aiming to open the competition in July and run it all the way throughout October, with the big final being played live during a workshop that we'll be organizing at AID in November. And we're also having a tutorial at IEEE CIG. And the tournament will be looking something like that. So we'll be having all the players pitted against each other, going through quarterfinals, semifinals, and the grand final. And to decide our final winner, that may actually be sitting here amongst you. So you are very much strongly encouraged to follow the project. Check out the Project Malmo website check out our competition website, and do send us our feedback and get involved. Thank you.
Thank you. We're a little bit ahead of schedule. Do you have any questions?
Get back up.
Malmo.
Yep.
You showed us where you define the arena and how you design it.
Mm-hmm. Yeah.
Is that a closed world spatial?
It can be whatever you want it to be, pretty much. So you can define sort of a barrier to narrow down your world and not allow the agents to run off and escape and do their own thing. But you can also leave it completely open and maybe give them a goal in a particular area of the game that they would have to find, but that doesn't have to be restricted in any way.
So is the agent aware of all the items and all the things in the world from the get-go?
The agent has access to all sorts of observations. One of the possibilities is to tell it exactly where everything is and what it is. Another option is to give it only the visuals that it would see in a first-person view. So it has to actually walk around like a human would and identify what it's seeing, realize its goal from that. Yeah, sure. Cool.
Any other questions? All right. Thank you very much.
Thank you.